Hello student, today we are going to start a new chapter in organic chemistry, that is halogen derivatives. It's the first and the most important chapter of organic chemistry. Now, so starting with the chapter, okay, first we'll understand what is halogen derivative, right? Suppose I take one compound, that is methane. Methane is CH4, right? This is methane. Now, if I replace one of the hydrogen by some halogen, right? Now, what is halogen? Halogen will be representing as X, right? And here, halogen can be fluorine, can be chlorine, can be bromine, and iodine. So, if I replace this hydrogen by halogen, so it will become C, H, 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 and X. So this compound of halogen is called halogen derivative. Clear? I hope you understand. Now the first part of the chapter will be dealing the classification. Classification of this halogen derivative. Now student, there are various classification, but in that the first classification is on the basis of hydrogen skeleton. On the basis of hydrogen skeleton. Now, what is this hydrogen skeleton? Let's understand. Now, for example, it can be classified as haloalkanes, so on and so forth. We'll understand one by one. First, haloalkane. As I explained here, it's the same thing. I take any alkane. For example, I take CH3. This is ethane. This is what? Ethane. Again, I replace one of the hydrogen by some halogen, right? Suppose that halogen is chlorine, so it will be CH3CH2 Cl. This is ethyl chloride. Now student, this compound of halogen is derived from alkane. That's why this is called haloalkanes. Clear? Now, similarly, there can be haloalkenes. Now, what is haloalkene? Take one alkene, that is, I take ethene, CH2 double bond CH2. Again, the same thing. I replace one of the hydrogen by some halogen, right? CH2 double bond CH, one hydrogen is removed, and I write instead of that X. X can be any halogen, can be fluorine, chlorine, bromine, iodine, whatever. So this compound is derived from alkene. This compound is derived from alkene. That's why it is haloalkene. Same way, it can be classified as it's a third classification, haloalkynes. Same way, I take alkyne CH triple bond CH. This is ethyne, or also called as acetylene. This is ethyne, or we also call as what? acetylene. Now in ethine, again one of the hydrogen is replaced by some halogen, right? Suppose I write here X2 or write X, CH triple bond C X. This will be called haloalkynes. Clear? Now it can be further classified as haloarenes. Now what is this arene? Halo means halogen, arenes. Arene means aromatic compound. For example, I take benzene, right? Now you do understand the structure of benzene. These are the carbon, and each carbon is also having one hydrogen. Now what I do, I replace this hydrogen again by halogen, and the product so obtained will be haloarenes, right? Clear, student? Okay. Now next classification is on the basis of number of halogen atom attached. So the second classification is, first classification was on the basis of hydrocarbon skeleton. Next classification is on the basis of number of halogen attached. Number of halogen attached. Okay. In that, the first one is monohalogen. The first one is what? Monohalogen. Right. Now monohalogen derivative of monohalogen compound. In this, only one halogen atom is attached. For example, again I take here CH, suppose CH3, CH3, right? If I replace one of the hydrogen, okay, suppose CH2 I'm writing, one hydrogen is replaced by chlorine. This is chloroethene. So how many halogen is attached? One halogen is attached in this compound. Okay, so that's why it is called monohalogen. Clear? Okay. Now student, next is dihalogen compound. Now in dihalogen compound, two halogen atoms will be attached to the given carbon. For example, suppose I have carbon, right? Now I have to attach two halogen. Now very important student, these two halogen can attach on the same carbon or can attach to the adjacent carbon, right? Now here first I balance the valency by putting hydrogen CH. Now both the halogen I am attaching to the same carbon. You can see here both the halogen is attached to the same carbon. Then it is called as geminal dihalide. So why this classification? Because I am attaching two halogen and both the halogen is attached on the same carbon. It is geminal dihalide. Dihalogen can be of two types, where in the first case both the halogen is attached to the same carbon, and in the second case, this is the first case and this is the second case, where it is called vicinal dihalide. Okay, how vicinal? Let's understand. Right here carbon and carbon, right? And one halogen attached to this carbon, other halogen attached to this carbon. Again dihalogen, but the halogens are attached to the adjacent carbon. When such is the condition that both the halogens are present to the adjacent carbon, then we call as vicinal dihalide. Clear? Now satisfying the valency, CH2, CH2. I hope you understood this. So dihalogen is of two types. One is germinal, other is vicinal. What is the difference between them? In germinal, both the halogen is attached to the same carbon. In vicinal, both the halogens are attached to the adjacent carbon. Right? Clear? Okay. Now student. Next, again on the basis of attachment, number of halogen atom attached, that is trihalogen derivative. Now student, in trihalogen derivative, suppose I have 3 carbon, right? And my halogens are attached on this 3 carbon. So this compound contains 3 halogen. Now satisfying the valency, CH2, CH, CH2. This can be the example. Or I take one benzene. Here again I am attaching 3 halogens, right? One here, one here, one here. Okay, not necessarily one after the other. It can be one can be here, second can be here, third can be here, right? It can be attached anyways. Since in this compound 3 halogens are attached, it is trihalogen derivative. Okay, now in this we have to understand few examples, students. They are very important. Suppose I take methane. So in methane, I have one hydrogen, I have 4 hydrogen, right? But here the hydrogen, if I replaced by Cl, all the 3 hydrogen, if I replace Cl, right? This is nothing but chloroform. Chloroform. In same manner, if I write CH and I3, this is hydroform. If I write CH, methane, again replacing all the 3 hydrogen by Br, it will be bromoform. Right? This is again a trihalogen. Why trihalogen? Because in the compound 3 halogens are present. 3 halogens are present. Right? Okay. Now, next one is, there can be one more, tetrahalogen. Now, in tetrahalogen compound, again I take methane and I replace all the hydrogen by chlorine. This is tetrachloromethane. Clear? Right. So this classification was based on the number of halogen attached. Right. Now student, moving to the next classification. This classification is based is of classification of monohalogen compound. Monohalogen compound. Now, what is this classification? Let's understand. It's very important. In this, first is we call alkyl halide or haloalkanes. Now we have seen it before. Haloalkanes means I have alkane, right? Suppose I take alkane, that is ethane, right? Now here in this case, condition is the halogen must be attached to the carbon which is sp3 hybridized. sp3 hybridized. I hope you understand what is hybridization, right? Now if I take this compound, so in this compound, both the carbon is sp3 hybridized, right? Now if I remove one of the hydrogen, okay, and I attach this halogen, suppose I remove this hydrogen, right, and I attached halogen over here, okay, so this is called alkyl halide or haloalkane, and here the condition is the halogen attached to carbon, this carbon should be sp3 hybridized. That is the condition. Clear? Now it can be further classified as 1 degree alkyl halide, 2 degree alkyl halide, and 3 degree alkyl halide. Now student, this example, can you tell me what is this belongs to which category? 1 degree, 2 degree, or 3 degree? Tell me. Yes, it belongs to 1 degree. How 1 degree? Because this carbon is attached to only one carbon. So this is 1 degree carbon and my halogen is attached to the 1 degree carbon. So that's why it is 1 degree alkyl halide. Clear? Now student, moving to the 2 degree alkyl halide. At a carbon, carbon, carbon. Now student, this is 1 degree carbon, this is 2 degree carbon, this is 1 degree carbon. If my halogen get attached on this carbon, that is 2 degree carbon, then this is called 2 degree alkyl halide. Now satisfying the valency, that's quite simple. CH3, CH and CH3. Okay, we can write my example also. Suppose CH3, CH, CH3, I write here Cl. Can you name this? This is 2 chloropropane. Clear student? Okay, and also this is 1 degree, this one is 1 degree, this is 2 degree. I write the 3 degree example here. So 3 degree alkyl halide. Now I take this carbon, this carbon, this carbon, and this carbon. Now this carbon is a 3 degree carbon because it is attached to 3 carbon, right? If my halogen is attached to this carbon, 3 degree carbon, so this will be 3 degree alkyl halide. Again, satisfying the valency of carbon, right? So this is 3 degree carbon, 1 degree carbon, 2 degree carbon, and 3 degree carbon. Clear? Again, I am repeating one thing, student. This type, what is the condition for this type of alkyl halide? Condition is my halogen should attach to the carbon which is sp3 hybridized. In this, it is can be of 3 type, 1 degree, 2 degree, 3 degree. You can understand this. Here also, the hybridization of carbon is 1, 2, 3, and I hope you know what is hybridization. If not, go and study that is present, right? And here